Hello everyone, I'm SHARVINNY GANESH. So today I'm going to explain my project. So basically, I am the creator of the Tempoyak Lab Digital Framework. My research focuses on bridging the gap between traditional food microbiology and modern web technology by leveraging computational tools and accessible front-end architectures. This project maps, tracks, and visualizes the chemical and microbial pathways of spontaneous durian fermentation to unlock its potential application. Next, talking about the summary. So basically, the durian post-harvest problem. The summary here is: durian is highly perishable assets. Durian is highly valued tropical fruit, but it possesses an exceptional short post-harvest shelf life of just 2 to 3 days before spoilage sets in. This rapid degradation causes massive post-harvest losses, particularly when surpluses occur in physical blemishes render the fruit visually unsealable. The scientific solution is control lactic acid fermentation, which is producing tempoyak, stabilizes the pulp, dropping the pH and preserving the essential nutritional elements naturally. The other hand, talking about importance of tempoyak is: so why we have to study tempoyak fermentation? Basically, the importance of tempoyak fermentation is wastage recovery. So this salvages low-grade, cracked or overripe durians which would otherwise be discarded, driving rural bioeconomic value. Secondly, we have probiotic source, isolated resilient indigenous lactic acid bacteria (LAB) strains with high survival rates in human gastrointestinal tracts. Thirdly, we have starter cultures. This enables standardization of local industrial starter cultures for dairy-free yogurts, reducing dependency on imports. Now, I will explain meaning of each point. We have dynamic kinetic analysis here, and then we have the graph here. Next, talking about life calculus score, we have instantaneous rate of change, which is 0.025 gram per liter per hour. This is the exact rate which lactic acid bacteria are acidifying the durian pulp at this exact millisecond. So we have mathematical substitution coding here. So let's play a run. So when this lactic acid program increases, the acidification rate will increase until it came to the optimal stage, and then it will decrease. So basically, we have layman's translation and industrial action. So what is happening biologically? Basically, acid levels hover near maximum capacity, which is around 14.5 to 15 gram per liter. At this stage, the derivative of F'(x) approaches 0. The metabolic machinery has slowed and the pulp has reached stable acidity. The tangent line is nearly horizontal. So this is the tangent line, which is the red color. Next, moving to the action for agro-product technologies, packaging and logistic window. The tempoyak is mature, high acidity, which is the pH is around 4.0, has fully preserved the product. It can now be mechanically processed into final retail tubes or cold stored for export, secure in its biological preservation. Next, let's talk about scientific foundation and kinetic modeling. The mathematics of fermentation kinetics we have here for the primary function of lactic acid yield, which is Fx is equals to L over 1 plus exponent to the power of negative k in bracket x minus x initial plus c. So to discover the instantaneous rate of acid production, we have first derivative of production rate, which is F prime x is equals to L times k times exponential of power of negative k in bracket x minus x initial over 1 plus exponential power of negative k in bracket x minus x initial to the square. So we have the parameter constants here, L, K, X initial, and C. Next, we have the bioscience scenario, which is for tempoyak. So basically, tempoyak is an authentic Malaysia fermented condiment made from the pulp of durian. And then I already explained this in a previous part. So we have the derivative of F prime X is critical because it helps for pH stabilization, heat and gas management, texture and flavor synthesis. So Malaysian scientific references utilizes this part. Next, talking about how to enhance the tempoyak lab web page. So the HTML recommendation integrated a lightweight visual charting engine like chart.js directly inside the HTML structure. Adding responsive canvases allows the page to dynamically plot critical fermentation kinetics. For example, the pH drop matching bacteria population growth curves from user-uploaded C5V files. So the current architecture we have here is the GitHub pages. Repository serves primarily as a static host for reporting lab metrics, datasets, and simple tables. While highly informative, the lack of real-time responsiveness limits the researcher's capability to analyze live kinetic correlations between different experimental variables. That's all from me. Thank you. So, Malaysian scientific references utilizes based on this. So, that's all from me. Thank you. Next, I'm passing it to my friend.
Okay, my part. Good afternoon, everyone. My name is SHARVINNY Abdullah, and I would like to present my HTML project titled BSF, Lava Biomass Growth and Derivative Optimization. Okay, this project focuses on black soldier fly larva, also known as Helminthia illusion, and how calculus can be used to identify the best harvesting time for maximum protein production. Okay. Next, I will explain the summary of the choose Bioscience problem. Malaysia face food security challenges because animal feed ingredients become more expensive. Okay, therefore researchers are studying black soldier fly larva has alternative sustainable protein sources. This larva can convert food waste into high protein biomass efficiently. However, one important problem is determining the optimal harvest time. If the larva are harvested too early, the biomass is still low. If harvested too late, the larva become purple and the protein quality decreases. So this project uses a mathematical model and derivative to identify the peak growth rate for the best harvesting period. Okay, now I would like to explain the importance of studying this bioscience problem. This study is important because it helps improve food security and sustainable agriculture in Malaysia. By using black soldier fly larva, food waste can be reduced while producing an affordable protein source for livestock feed. Besides that, this research also helps farmers optimize production efficiently. Reduce the use of calculus in Bioscience also show how mathematics can help solve real-life agriculture and biological problem. Okay, next I will click and explain the meaning of each point in this HTML website. Okay, first section explain the food security challenge. They describe how Malaysia is vulnerable to animal feed price increase and explain how BSF larva a sustainable alternative protein sources. Okay, next is mathematics model section. The cumulative biomass function Fx show the total larva biomass grow over time. The first derivative x represent to internal growth rate of the larva. This derivative help identify the point where growth is at in maximum. Okay. The next point is the optimal harvest date, which is day 10. This means the larva achieve a high growth efficient on day 10 with a peak growth rate of 22.50 mg per day. Next is the life biological optimization chart. The green line show cumulative biomass growth, while the blue line represent the growth rate. The graph clearly shows that the derivative reaches its highest point around day 10 before declining afterward. Lastly, the optimal harvest window section explains the harvesting on day 10 allow farmer to option maximum protein efficiency while reducing farm cost and waste. Finally, I would like to recommend one way to improve the HTML website. One suggestion is to add more interactive animation or hover effect to make the website more engage. Sorry, I'm nervous.
It's okay.
And easy to use to understand. For example, displaying explanation automatically when user hover over formula or graph would improve user experience. That's all for my presentation. Thank you for listening.
Okay, you may start now.
Okay. Hello everyone. My name is Muhammad AIMAN bin BADRIHISAM, and today I am happy to share my project with you, the Paddy Biomass Derivative Simulator. This is an wheat farming. It uses maths idea to track how a specific Malaysian rice variety, called Mardi MR297, go over its 120-day life cycle. My goal is to help students and farmers grow more food efficiently. Okay. Let's talk about the problem this tool solves is farming timing is everything. Many farmers use fixed calendars or just guess when to put fertilizer on the rice fields. However, if you apply nitrogen fertilizer too late, like when the rice grains are already filling out. The plant cannot absorb it will. This was a lot of money, creates criminal pollution in our water and leads to a smaller harvest. Okay, next, what is this problem? So important to study is directly affect food security and the environment. Okay, by using simple maths, we can stop guessing and start knowing exactly what the plant is. Math help us find the exact day the rice crop is growing at absolute fastest speed. If we apply fertilizer at these perfect moments, the plant grow much better. We produce more rice for the country and we avoid pollution our soil and river with wasted chemical. Bawah medical formulations. Okay, now let me show you how the simulation works. It uses a growth curve with three main settings. Carrying capacity L. Moving the slider changes the maximum weight the crop can reach. This depends on good soil and sunlight. No. 2. Ground coefficient K. This changes how steep the curve is, showing how weather or stress effect go. Last, midpoint D. X. This show the middle of the growth cycle, usually around day 60. Okay, on the graph, the S-shaped line show the total biomass. The hill-shaped line show the growth rates, which come from the math calculus. If I click right on the top of this hill, the simulation tell us the exact the rise in growing fastest. The tool gives you an analysis saying this is your final deadline to add fertilizer. If you add it after this, they bullets. Okay, now to make this website even better, I recommend live data upload buttons. Right now, user have a chance the setting manually by moving slider. If we add a feature where farmer can upload real weather data or soil reading from their ARIF file, the website could automatically calculate the perfect fertilizer they further. This would turn this educational tool into a real life helper for local farmers. That's all.
Alright, next we would like to pass to the other presenter.
Hello everyone, I'm Muhammad SYAHRUL AFZAN RUSDI and my number metric F25A1760 and I'm from SFPA Group Product Technology and my point is a group Bioscience calculus, oil palm refining analytics. So, in our local palm oil industry, timing isn't just money, it's everything. The core challenge for producers is maximizing the oil extraction rate, or OER. To achieve this, fresh fruit bunch must be harvested at their absolute peak biological maturity. But nature gives us a capability in a narrow window. If a plantation harvesting team cuts the fruit too early, lipid biosynthesis is incomplete. We are essentially leaving oil on the tree. Conversely, if we harvest too late, the fruit detach, fall, and the trigger repeat enzymatic degradation. Despite the level of free fatty acid FFT is severely destroying the oil quality and lowering its market volume. All problem statement is clear. First, economic sustainability. Malaysia is one of the world's top producers of palm oil. A mere 1% variance in OER across the nation equates to hundreds of millions of ringgit in economic yield By removing guesswork from harvesting schedule, we protect national GDP. Second, resource efficiency and waste reduction. In agriculture, efficiency means sustainability. By understanding the precise timeline of lipid accumulation, we optimize labor, reduce the need for downstream chemical, refining the correct high FFA levels, and maximize the output of every single hectare of land. Let's look at our biological model, which meant we measure oil content percentage FF again we after ATC or WAF. By utilizing a segment model growth function, we can use the first derivative, the instantaneous rate of oil production per week, to understand exactly what is happening inside the fruit. At 10 weeks. At 10 weeks after ATCs, the fruit is offensive. Physically, the internal mesoscale is watery and unformed. Statistically, both our cumulative oil content FF and our accumulation rate FX are near zero. Lipid diversity have barely intrinsic. Harvesting now uses nothing but water as cellulose waste. Now look at week 60. This is the inflection point of our segmental curve, and it represents a fascinating biological phenomenon at the exact moment. The left telemetry shows an accumulated rate of 8.94% per week. This is the fruit peak lipid metabolic speed. That's the fastest the plant will ever synthesize oil. However, look at the total oil content. It is at just 27.50%, which is only half capacity. As agrotechnologists, this is a vital threat to avoid. A high rate of production doesn't mean the fruit is ready. If we harvest now, we'll have our potential yield. You must allow the accumulation phase to measure. Finally, we reach week 22. Notice how the curve flattens out. Mathematically, the first derivative is approaching zero. The rate of lipid accumulation has completely plateaued. The biological machinery has finished its job, and the wet mesoscale oil content has reached its maximum physical capacity. This is the exact moment for harvest. Waiting any longer risks fruit rot and devastating FFA degradation. Before I conclude, I want to recommend one crucial way we can improve this interactive simulation to fulfill application. Right now, this simulation is perfect for an isolate laboratory setting. However, in the real world, biological growth factors change based on weather, soil quality, and region. I recommend integrating a parameter variance slider or a weather adjust toggle into the HTML interface. By allowing user to dynamically adjust the slope growth factor or the peak midpoint based on real-time rainfall or temperature data, our calculus model would transform from a static educational tool into a predictive real-time agronomy asset that plantation managers can use across various states in Malaysia. By marrying calculus with plant physics.
That's all from us. Thank you.